You've probably inflated your car's tires more times than you can count. At a gas station, in your driveway, or right before a long road trip, it feels like one of the simplest maintenance tasks there is. You attach the air hose, watch the numbers climb, stop at what feels right, and move on. But what if I told you that nearly 90% of drivers are doing this wrong? Not slightly wrong, not harmlessly wrong, but wrong in a way that quietly increases the risk of blowouts, damages tires from the inside, confuses safety systems, and compromises high-speed stability without ever triggering a warning light. Every year, repair shops across the country see thousands of vehicles with uneven tire wear, premature tire failure, suspension damage, and mysterious handling complaints. In many of those cases, the tires aren't defective, and the driver isn't reckless. The damage comes from a habit that feels normal, routine, and safe. Tire inflation mistakes don't announce themselves immediately. They don't make noise. They don't always trigger dashboard warnings. Instead, they work silently, mile after mile, slowly degrading safety, performance, and reliability. Most drivers believe tire problems only come from obvious mistakes like extreme overinflation or driving on visibly flat tires. But the most dangerous errors are far more subtle. They involve timing, temperature, inaccurate equipment, and misunderstanding how modern vehicles are engineered. These mistakes don't cause instant failure. They slowly weaken the tire's internal structure, reduce grip, and force electronic safety systems to compensate for conditions they were never designed to handle. To understand why this matters, you have to understand what a tire actually is. A tire isn't just a rubber circle filled with air. It's a complex, flexible structure designed to carry weight, absorb impacts, manage heat, and maintain traction under constantly changing conditions. Tire pressure is not a fixed value. It changes with temperature, speed, load, and time. Treating it like a static number is where most drivers go wrong. One of the most common and dangerous mistakes is inflating tires when they're hot. This happens constantly. You drive for 15 or 20 minutes, pull into a gas station, check the pressure, and notice it's a few psi low. So you add air until it matches the number on the sticker inside the door. It feels responsible, but it isn't correct. When a tire rolls, friction between the tire and the road generates heat. As temperature rises, the air inside the tire expands, temporarily increasing pressure. That means the number you see after driving is already inflated by heat. When the tire cools down later, the pressure drops. Without realizing it, you end up driving on underinflated tires. Engineering data shows that a tire running just 5 psi below its ideal pressure can operate significantly hotter at highway speeds. That extra heat accelerates wear, weakens internal components, increases rolling resistance, and raises the risk of structural failure. The professional rule is simple and absolute. Tires should always be inflated cold, ideally before driving or after the vehicle has been parked for several hours. Another widespread mistake is trusting gas station air pumps too much. These machines are convenient, but they're rarely accurate. They're exposed to weather, physical damage, and constant use, often without calibration. Independent testing has shown that public air gauges can be off by 2 to 6 psi. That's enough to push a tire well outside its safe operating range. Professional mechanics don't rely on these gauges. They use personal digital tire pressure gauges that are regularly checked for accuracy. These tools are inexpensive, often costing less than $20, yet they provide consistent and reliable readings. That small investment can prevent uneven wear, improve fuel efficiency, and preserve handling balance. Trusting a random air pump screen to protect your tires is a gamble most professionals simply won't take. Incorrect tire pressure also leads to uneven tire wear, one of the most expensive consequences of poor inflation habits. When pressure is too low, the outer edges of the tire carry more load, increasing sidewall flex and wearing down the shoulders. When pressure is too high, the center of the tread wears prematurely. Once this wear pattern develops, it cannot be reversed. Rotations, balancing, and alignments cannot fix pressure-induced damage. One major cause of this problem is using a generic pressure number for every vehicle. Numbers like 32 psi get repeated so often that many drivers treat them as universal. They're not. Every vehicle is engineered with specific tire pressures based on weight distribution, suspension geometry, braking forces, and load capacity. Ignoring those specifications forces tires to operate outside their design window. Incorrect pressure doesn't just affect tire life. It directly impacts braking performance and vehicle stability. Tires are the only part of the vehicle that touches the road. When pressure is wrong, the contact patch changes. Less contact means less grip. Even small deviations can increase stopping distances, especially during emergency braking. Modern vehicles rely heavily on electronic stability and traction systems. These systems assume the tires are inflated correctly. When pressure is off, the car behaves differently than the system expects. Sensors detect unusual wheel behavior, forcing the system to intervene more often. The driver may feel the car is unstable or unpredictable, without realizing the root cause is improper tire pressure disrupting the vehicle's safety systems. Fuel consumption is another hidden cost. When tires aren't properly inflated, rolling resistance increases. That means the engine has to work harder to maintain speed. Even a small pressure difference can reduce fuel efficiency by a noticeable amount. This loss happens gradually, so drivers rarely connect increased fuel costs to tire pressure. The correct pressure for your vehicle is not found on the tire itself. It's found on the manufacturer's label inside the driver's side door jamb. That label lists the exact pressure recommended for the front and rear tires, based on cold inflation. These values are calculated by engineers who designed the vehicle as a complete system. Many drivers overlook an important detail on that label. Often, the front and rear tires require different pressures. This is intentional. Most vehicles have uneven weight distribution, especially front-engine cars. Inflating all four tires to the same pressure disrupts vehicle balance and handling. Valve damage is another invisible issue. The valve cap acts as a secondary seal. Over-tightening it or threading it incorrectly can damage the valve stem, allowing dirt and moisture to enter. Over time, the valve core corrodes and develops a slow leak. The tire keeps losing pressure, and no one understands why. Valve caps should only be tightened by hand, never with tools. Low-profile tires add additional risk. These tires have short, stiff sidewalls and require higher pressures to maintain structure. When pressure drops, even slightly, impacts from potholes can cause internal damage or sidewall bubbles. Lowering pressure because it looks too high is an expensive mistake. Some drivers intentionally overinflate tires to improve fuel economy. While this may slightly reduce rolling resistance, it dramatically reduces traction, worsens ride quality, and causes rapid center tread wear. Any fuel savings are quickly erased by premature tire replacement. The most destructive mistake of all is driving constantly with underinflated tires. Sidewalls flex excessively, generating heat that weakens the tire internally. The damage isn't visible until failure occurs, often at highway speeds. That's why professionals recommend checking tire pressure at least once per month. Loading and towing introduce another variable. Many vehicles list different pressures for normal driving and maximum load. Ignoring this leads to overheated rear tires and increased blowout risk during long trips. Pressure must be adjusted when vehicle weight changes. Tire pressure monitoring systems add complexity. These systems are not precision tools. They must be reset after inflation to establish a new baseline. Without resetting, drivers may see false warnings or miss real problems entirely. Temperature changes also matter. Tire pressure changes roughly 1 psi for every 10 degrees of temperature change. Seasonal shifts alone can leave tires underinflated for months. In the end, tire inflation isn't about guessing. It's about understanding how a critical safety component works and respecting the engineering behind it. Proper inflation reduces risk, improves performance, saves money, and protects lives. That's not exaggeration. That's physics applied to driving.